Alright, you guys, let's jump into the Chapter 6, Sections 4 to 7 review. So in number 1, we have a radical divided by a radical, and we want this in simplest form. Now, in order to divide, we need our indexes to be the same number, and they're not here. So we can't divide while it's in radical form. So what we're going to do is change it to rational form. So in our numerator, the 6th root of x to the 4th becomes x to the 4/6. And in our denominator, the 9th root of x to the 4th becomes x to the 4/9. And now we can divide because our bases are the same. Our bases are x. So our base will stay the same. We'll have x. And then we will subtract our exponents. So 4/6 minus 4/9. Now 4/6, we can reduce that. 4/6 becomes 2/3 minus 4/9. And then we need to have the same denominator. So to make it the same denominator, we can multiply the first fraction by 3 top and bottom to make that 6/9 minus 4/9. Oops. And when we subtract 6/9 minus 4/9, we get x to the 2/9. And so our answer here is going to be C, x to the 2/9. Alright, for number 2 and 3, we want to write the simplest form of each number. In number 2, we want to multiply. That's what these parentheses indicate. But we can't multiply these because we don't have the same index. We need the same index in order to multiply. So our option here is to change forms. So the first one, the square root of 2, becomes 2 to the 1/2. And then inside, the 8th root of 2 becomes 2 to the 1/8. And that's supposed to be an 8. Here we go. Alright, now in rational form, we can multiply because we have the same base. So we're going to keep that same base of 2, and we're going to add the exponents. We add exponents when we're multiplying. So 1/2 plus 1/8. Well, in order to add these, we need the same denominator. So this is really 2, and if we multiply the 1/2 top and bottom by 4, it will become 4/8 plus 1/8. And now adding those together, we get 2 to the 5/8. So our answer here is going to be B. Looking at number 3, we have 25 to the negative 1.5. So first of all, we can't have a decimal as our exponent. My words left me. Alright, so we can't have a decimal as our exponent. So negative 1.5, I could put that over 1. And then anything that ends in a 0.5, if you multiply that by 2, and what you do to the top, you have to do to the bottom, that will give you a whole number. So I'll have negative 3 over 2. So what I really have is 25 to the negative 3 over 2. Now you can change 25. You could change the base, or you could change it to radical form. It's your choice. I'm going to change my base, and I'm going to make this 5 squared, because that's what 25 is, and that's raised to the negative 3/2. Now when you have a power to a power like this, power times a power, or a power raised to a power, we're going to multiply. So we have 5 as our base, and then 2 times negative 3/2 becomes just negative 3. The negative is going to bring our 5 to the bottom. It's not happy where it is, so it's changing location. So I have 1 over 5 to the 3rd, and then 5 to the 3rd is 125. It's 5 times 5 times 5. So our answer here is A. Alright, so now let's take a look at a word problem. This is the same word problem that we had in class, you guys. We're just using different numbers. So don't shy away from it. You're going to have a question just like this on your test. It says you have a coupon good for $6 off the price of any large pizza. We're going to make this function f. And function f is in terms of x, where x stands for the price of a pizza, f of x. So, alright, let's look at number 5. It says the store is offering a 25% discount on all items. Also, employees get a 10% employee discount. If you're an employee, which discount would you want to be applied first to save the most money? Well, remember that discounts is multiplication. So it's saying, should we multiply this and then multiply this? Or should we multiply this one first and then multiply this one? And you want to remember that multiplication, the order doesn't matter. So we don't have to do any work here. We know that in order to save the most money, it doesn't matter which discount is applied first. The result is the same. Alright, number 6 and 7 says simplify. So we're multiplying in number 6, and in order to multiply, we need to have the same base, and we have the same base of 20. So when we multiply, we keep that same base, and we just add the exponents. So 1/2 plus 1/2, that's going to be 20 to the first, which is just 20. 20 is our answer. In number 7, we don't have the same bases. So we need to either change forms or we need to change bases. If I change the form for number 7, then I get the cubed root of 3 times the cubed root of 9. And in order to multiply here, you need the same index, which you have. So multiplying on the inside, we keep our index, cubed root, and 3 times 9 is 27. And then you know the cubed root of 27, if you break that down using the border method, 3 goes in 9 times, 3 goes in 3 times, 3 goes in once. And you need 3 to come out. So our answer is 3. Number 8 says write the exponential expression 3 times x to the 3/8 in radical form. Alright, well, let's deal with one at a time. We actually have 2 terms here. One of our terms is 3, and the other one's x to the 3/8. Well, 3 doesn't have any exponents, so 3 is going to stay on the outside. X, though, has that rational or fractional exponent of 3/8. So 8 becomes the index, x is what's on the inside, and 3 is our exponent. So this is our answer. Alright, number 9, we want to write in simplest form. So first of all, we have parentheses, and then inside these parentheses we have 2 terms. We have the 8, and we have the a to the negative third. So we have to distribute this negative 2/3 to each of those terms. So it's going to be 8 to the negative 2/3, and then a to the negative third, which is raised to the negative 2/3. Because we just took this and we distributed it to each one of these inside. Alright, so we just deal with one at a time. So dealing with the 8 first, we can either change form or we can change base. This time I'm going to change the base. So I'm saying 8 is really 2 to the 3rd power, and that's being raised to the negative 2/3. Well, when you have a power times, or a power raised to a power like this, you multiply. So I'm going to have 2 to the negative 2, and the negative's going to change location, so it's 1/2 squared, and then simplifying 2 squared, that becomes 1/4. So that's simplifying this first part. Now let's go back and simplify the a to the negative third. So simplifying this part now, again we have a power to a power, so we multiply. So we have a, the negatives cancel out, and it just becomes a squared. Well, that's a variable, so there's nothing else we can do with that, so we're just going to bring this down with our 1/4, and we can either put it next to it and say 1/4 times a squared, or we could put the a squared on top and put the 4 on bottom. So either of those are correct answers. Alright, number 10 says, what is the solution of the equation? So we're trying to solve for x. So the first thing here, since x is inside of a radical, is to isolate our radical. So I'm going to draw a box around that, and to get that isolated, I'm going to add 7 to both sides of my equal sign here. So now I have the square root of x plus 10. This is equal to negative 5 plus 7 is 2. Now that I've isolated the radical, to get rid of it, I'm going to do the inverse operation. So the inverse of square rooting is squaring. Because our index is really a 2, I'm going to square both sides. And those are going to cancel each other out. So I get x plus 10 is equal to 2 squared, which is 4. And now lastly, to get x by itself, we're going to subtract 10 on both sides of this equal sign. So I see that x is equal to negative 6. And here's my answer. If you wanted to check it, you could just plug it in. So for x, we'd say negative 6 plus 10, and then minus 7. Is that question mark equal to negative 5? So inside we get 4, and then minus 7 is equal to negative 5. Square root of 4 is 2. Is 2 minus 7, is that equal to negative 5? And yes, that works out. Alright, you guys, we're halfway through this, so stay focused. I'm trying to get through it as quickly as possible. Alright, so we're on number 11. We want to solve, and we see this is in rational form. So the first thing we want to do is to isolate this term right here, and realize it's already isolated. So now we just have to get rid of it. So we have x plus 6 to the 3/5, and we want to get rid of that 3/5, that exponent. So what we're going to do is multiply by the reciprocal. So 5/3, and that's what I'll do on this side too. When I do that, these are going to cancel each other out. So I'll get x plus 6 is equal to 8 to the 5/3. Now we need to simplify this over here. And you can simplify it two ways. You could say 8 is really 2 cubed, and that's being raised to the 5/3. So then the 3's cancel out, and 2 to the 5th becomes 32. Or you could say, change it to radical form and say the cubed root of 8 to the 5th power, and the cubed root of 8 is 2, and then raised to the 5th power is 32. So either way, if you want to change the base up here, or if you want to change to radical form, but either way you need to simplify that. So x plus 6 we now know is equal to 32, and to solve we're going to subtract 6 on both sides. So x is equal to 26. Alright, number 12 says find f of x plus g of x. So all we're doing is adding these functions. So f of x, that's equal to negative 5x minus 4 plus g of x. So plus g of x is 6x minus 7. So all we're doing is combining like terms here. So we see we have a negative 5x and we have a positive 6x. So when we combine those, I get a positive 1x. I have a minus 4 and a minus 7, so combining those I get a minus 11. So here's our answer. Alright, number 13, we are subtracting now. So f of x is x plus 1, this is our f of x, and minus g of x. So with minus we're going to put parentheses around the second function, and we're going to say 2x plus 2. Remember with the minus sign we have to distribute it to each term on the inside. So x plus 1 minus 2x minus 2. And now we're just combining like terms. So x, negative 2x, when you combine those you're going to get a negative 1x. And then positive 1 minus 2, combining those you get a negative 1. So here's our answer here. Alright, number 14. It says find f times g and its domain. So we're multiplying. Don't mistake that for composition, it's a closed circle. And we're multiplying f, which is 3x plus 2, and we're multiplying it with g, and g is 7x plus 6. And notice I threw parentheses around each to indicate that I'm multiplying. So what we're going to do here is basically FOIL or double distribution. So 3x times 7x is 21x squared. 3x times 6 is a positive 18x. 2 times 7x is a positive 14x. And 2 times 6 is a positive 12. So combining like terms, I see my middle terms are similar. So I have 21x squared plus 32x plus 12. And there's nothing else to combine, so this is my answer. And for my domain, well, I see that x is not in a fraction and it's not under a radical. So my domain is all real numbers. All right, in number 15, we are dividing. So f's on top, and we have, oh, I don't even need a parenthesis. F's on top, and we have 5x minus 5. And on the bottom is g, which is x minus 1. Before we do anything, since we need to state its domain, right away we need to say our domain is all real numbers, except x cannot be equal to 1. And we're deciding on 1 because if we plug in 1 here, then 1 minus 1 would give us 0. And we're not allowed to have 0 in the denominator. Alright, so we go back up to our fraction and we want to simplify it. So in order to simplify, we're going to try to, we're going to try to factor. So on top, we look for GCF, and there is one. It's 5. So 5 comes out, and we get x minus 1. On the bottom, we try to factor, but there's no GCF, and it's not a difference of squares, so it just stays x minus 1. Luckily, we're able to cancel out both the x minus 1's, and our answer here is just going to be 5. So our answer is 5, and then our domain is all real numbers where x can't be 1. Alright, number 16, we're looking at a composition of functions. F of g of negative 5. So we start on the inside, the one closest to the number. So f's out here, but then function g is negative 4x plus 3. And instead of the x, I'm going to substitute it with this negative 5. So it's f of negative 4 times negative 5 plus 3. And simplifying this inside, negative 4 times negative 5 is 20, plus 3, and 20 plus 3 is f of 23. So now I need to look at function f. Function f is negative 2x minus 7. But I'm going to take this 23 and plug it in. So negative 2 times 23 minus 7. Negative 2 times 23 is negative 46 minus 7. When we subtract those, we get negative 53. So negative 53 is my answer. Alright, number 17 is also a composition of functions. Recall that this is just another way to write it. So the first function we're going to look at is function f, since it's closer to the number. So we're going to say g of, and then function f is x plus 2. But instead of the x, we're going to plug in this negative 5. So it's g of negative 5 plus 2, and when we simplify that, it's g of negative 3. So now I'm going to look at function g, which is x squared, and instead of the x, I'm going to plug in the negative 3. So it's negative 3 squared, which is 9. So our answer here is 9. Alright, number 19. It says, is relation t a function? Is the inverse of relation t a function? And it says, what is the inverse of the given relation? So we have 3 questions to answer here. The first one, is relation t a function? Well, to see if it is a function, we have to look at our x, and we have to see if any of these values here repeat. So 0, 2, 4, 6. Did we have any of them more than one time? And the answer is no. They're all different from each other for the x. So, first question, is it a function? Yes. Second one says, is the inverse of relation t a function? Well, first we have to find the inverse. So let's answer number 3 first. What is the inverse? So we just switch the x and the y values. So 0, negative 8 becomes negative 8, 0. 2, negative 7 becomes negative 7, 2. 4, negative 4 becomes negative 4, 4. And 6, negative 4 becomes negative 4, 6. So that's our answer to what is the inverse. And then coming back to the top, saying, is the inverse of relation t a function? Well, again, we're going to look at our x. We're going to see if any of these repeat. Negative 8, negative 7, negative 4, negative 4. Yeah, we have negative 4 twice. So, no, the inverse of relation t is not a function. Alright, and our last question, what is the inverse of the given relation? So remember, to find the inverse, our first step is to switch the x and the y. So x is equal to 3y plus 9. Now we just need to solve for y. So we're going to subtract 9 on both sides. And we have x minus 9 is equal to 3y. And then 3 and y are multiplying, so to undo it, we divide by 3. So we have x minus 9 over 3 is equal to y. Last step, just flip-flop it. So y is equal to x minus 9 over 3. And that's our final answer. That's our final question. You guys rewatch this again if you need to, or rewind to a specific question. See me in the morning if you have any questions about any of these problems. Good luck studying, and I'll see you tomorrow.